Dear students, in your previous lecture, we have discussed about the wall timing diagram for four-stroke petrol engines. So today we are going to discuss about the wall timing diagram for the four-stroke diesel engine. So here you can see the theoretical and actual wall timing diagram uh, for the diesel engine. So here you can easily see that. So here if you are first of all we will analyze the theoretical wall timing diagram. So in diesel engine, so inlet valve will open exactly when piston is at top dead center. So inlet valve opening in theoretical wall timing diagram, we are opening the inlet valve when piston is at top dead center, and piston is moving from top dead center to bottom dead center by performing the process of suction process. So after suction process, piston will come at the bottom dead center and inlet valve will get closed, and then again there will be the reversal of direction of piston will be happen, and piston will move from bottom dead center to the top dead center, performing the compression of the processes. Means whatever the air is there, that will get compressed due to the movement of piston from bottom dead center to the top dead center. Just before the end of the compression, we will inject the fuel. Inside the we are injecting fuel inside the combustion chamber. So as soon as the fuel is injected into the combustion chamber, due to the high temperature of the air, it will get ignited and burning of fuel will be occur, and due to that large amount of pressure will get generated, heat will get released, and due to that there will be the expansion of gases will be occur, and due to that piston will move from again top dead center to bottom dead center, and exactly at the bottom dead center will open the exhaust valve. As soon as we are opening the exhaust valve, heat rejection will be occur at constant pressure, constant volume. Heat rejection will be occur at constant volume, and then piston will move from bottom dead center to the top dead center, and exhaust of gases will be occur in during this process, and at the end, when piston is reaching at the top dead center, exhaust valve will get closed. Now here here, if you are following the theoretical wall time diagram, so we cannot produce the uh, high power. Again, we cannot engine will not perform better. So for better performance of the engine, what is the requirement? We have to increase what we have to increase the volume sucked by the cylinder. That is our one objective. That is our one objective. So that objective is very important. What is the objective? What we have to do, we have to increase the volume of suction charge. Whatever the charge we are sucking, that volume we have to increase. So for increasing the volume of suction charge, what we are doing, we are modifying the wall timing. We are modifying the wall timing, and in reality we are not opening the inlet wall and exhaust wall exactly at the dead center. So we are increasing the time so that the wall remains open, and we can get the maximum amount of charge inside the cylinder during the suction process. So for that, in diesel cycle, instead of opening inlet wall, instead of opening at the top dead center, we are opening just before the 20 degrees before the top dead center. So here we have opened the inlet wall 20 degree before the top dead center, and we have closed the inlet wall 30 to 40 degree after bottom dead center. So what we did, we have increased the during the wall will remain open. So this duration of opening we have increases. So this duration of opening we have increases so that we can increase the volume of suction charge inside the cylinder. So as the maximum volume we are sucking, so we can produce the maximum power, okay, during the for for that speed of the engine, so during this process, inlet valve is opening 20 degree before the top dead center, and then it is the piston is moving from TDC to BDC, achieving the suction process, and this valve will close after the BDC 30 to 40 degree after BDC, and then compression process will be occur. So after from here, so this compression process is occurring, and at the end of the compression process, just before the 15 degree before the top dead center, we are starting the injection of fuel. What we are doing, we are starting the injection of fuel, and we are closing the injection of fuel 30 degree after top dead center. So this is the fuel injection is starting. So from here we are injecting the fuel, and we are closing the fuel injection after 30 degree after BDC. So during this process, as we are injecting the fuel, as well as they are coming in contact with the compressed air, so temperature and pressure of the compressed air is higher, so simultaneous heat combustion of fuel will be occur, and due to that heat will get released, and as the release of heat, there will be the expansion of gases will be occur, and due to that piston will move from TDC to BDC. So from here this process is indicating the expansion process. We are engaging in the expansion process. Again, for achieving the better performance of engine, so again we have to increase the maximum amount of byproduct of combustion to the atmosphere, so that again we are increasing the duration of exhaust valve opening, so for that we are opening the exhaust valve not at the bottom dead center but before the bottom dead center, and we are opening the exhaust valve before the bottom dead center, that is 30 to 40 degree before the bottom dead center. So here we have opened the exhaust valve, and as exhaust valve is opening, so here heat rejection will be occur, and from here again exhaust of gases will be started as the piston is moving from bottom dead center to the top dead center, and we are not closing the exhaust valve exactly at top dead center, we are closing the exhaust valve 15 degree after BDC. We are closing the exhaust valve 15 degree after BDC, so that we can increase the time to remain exhaust valve open, so this is the wall timing diagram. And what we are doing, that is the very important, because what we have to do, we have to increase the volume of suction charge inside the cylinder. What we have to do, we have to increase the volume of suction uh, we have to increase the volume of suction charge, so that we can produce the more power and engine will perform better. So this is important thing you have to. Now we have to analyze this wall timing diagram again precisely. Now I am asking you the questions now, whether we can change the wall timings. We can change the wall timing, we cannot change the wall timing because we have fixed it. So already this wall timing is fixed. If you are thinking about the inlet wall timing, so this wall time is fixed. This the time to remain inlet valve open, that wall time is fixed, and due to that, what is the amount of charge coming inside the cylinder, that is also fixed. So here this fixed wall timing is here, so we are not changing depending on the load. We cannot change this wall timing depending on the load. So what will happen now, you think that if the load is low, we can say starting, when we are starting the engine, at that time load is very less. Load is very less, so at that time the requirement of charge is lower, very low. We have to suck least amount of least amount of charge inside the cylinder, so that we can produce the less power to start the engine. We can produce the less power to start the engine. And the opposite case, so this is the first case is there, when we have to start the engine, at that time we need a least amount of charge and we have to produce the least amount of power. But as the inlet valve and exhaust valve are opening and closing at that fixed time, so this duration of wall timing is fixed, so this time is fixed. So due to that, the whatever this so for and in the opposite cases, if the we have to increase the speed, we have to increase the speed. And if the speed is increasing, if the speed is increasing, so engine will require the more power, it will require the more power. But what will happen if you have designed this wall timing at some medium speed level, for medium speed level, so we cannot design this wall timing for slower speed, higher speed, or medium speed. At variable speed we cannot design this one. So when we are designing this inlet wall and inlet wall opening time, so we will design for specific speed, we will design for specific speed. And yeah, as we are designing this wall timing for specific speed, so this whatever the time it will take, that will vary depending on the speed. So this time will be vary depending on the speed. So for understanding this, we have to understand how the wall will open with the help of crank, with the help of sharp power, crank sharp power. So we'll look that one, we'll look that one. So here, now see, this is the diagram. So this is the diagram. So here you can easily look. So this is the crankshaft. So what is this? So this is the crankshaft. So this is the crankshaft, and this crankshaft transferring power to the camshaft. So this is the camshaft. So what is this? This is the cam and this is the crank. So this is the crank and this is the belt. So this is the belt. So this crankshaft is controlling the camshaft. It is controlling the camshaft. It is controlling the camshaft. It is controlling the camshaft. Now, as this crankshaft is controlling the camshaft, we can say that. So this crankshaft, it is controlling this camshaft. Now this camshaft will rotate, and due to the rotation of the camshaft, so we can say that lift, we can say that if we are this design of cam profile is such that, so it will be, there will be the lift, and there will be the again dwelling. So this dwelling time, so now we can say that this dwelling time, so whatever the time required for dwelling, that will decide the opening of the wall. Now this transforming the power to the camshaft, and this camshaft is rotating, and due to the rotation of this camshaft and due to with the design of this cam, so whatever the dwelling period is there, for that dwelling period, this wall will push this spring and it will open the wall. So it will keep open for that dwelling period, Now we are relating this dwelling period with the speed of the crankshaft. Now you think that the speed of the crankshaft is lower. Now speed of crankshaft is lower. As the speed of the crankshaft is lower, so whatever the controlling output for this camshaft will be lower, and due to that, the moment of, so angular movement of this crankshaft will be lower, and whatever the time required to rotate this camshaft will be higher, it will be higher. And when the speed is lower, it will the time, whatever the time is there, whatever the time for time of opening, so time of dealing will be higher, it will be higher. Now you think that, now the second case, now what is the second case? Now this crankshaft, it is having the higher speed, it is rotating at higher speed, and as it is moving at the higher speed, this camshaft will be rotate at with higher speed. As it is moving at the higher speed, so what will the time of dwelling will be lower. Time of dwelling will be lower. So whatever, this is the lift of the cam and this is the dwelling of the cam. So this dwelling time will be lower at higher speed. Now this is the disadvantages, because at higher speed, so time should be higher, it should be higher, and for at lower speed, means at the starting of the engine, this time should be less. So it is doing the opposite work, means whatever the time required at the lower speed, it should be lower, and whatever the time required of opening of the wall is higher for higher speed. So for recovering these disadvantages, we are applying the variable wall timing diagram. In previously we have discussed about the fixed wall timing diagram, fixed wall timing. Now we have to apply the variable wall timing, so that we can remove this disadvantage, and we can reduce the time at the lower speed, and we can increase the time of opening of the inlet valve at the higher speed, so that we can vary the charge depending on the load, because at the lower speed there will be the load will be lower, so we require the low volume of suction charge. When the speed is higher, there is the load is higher, so at that time we need a high volume of suction charge. So that is overcome by the application of variable wall timing diagram. Same thing in previous in this diagram. So this is the overhead type camshaft. This is the overhead type camshaft. Just above the wall we have provided the camshaft. So this arrangement we are calling at the overhead type of camshaft. In next one we are using the rocker arm. Here we are using the rocker arm. So here what we are using the rocker arm. This is the crankshaft, and these are the push rod. This is the crankshaft. These are the camshaft. So this is the cam, this is the crank, and we are using the after cam we are using the push rod, and these push rods are connected with this rocker arm. This is connected with a rocker arm. This is connected with a rocker arm, and this, as we are pushing up, so it will push down and it will get open the wall. It will open the wall. It will remove the spring forces and it will open the wall. As the push rod is going upward, this rocker arm will push the wall downward and it will open the walls. So this is important, because we have to understand how we can vary the time. If you are using the fixed time, so we can see that at lower speed the higher dwelling period we are getting, at higher speed we are getting the lower dwelling period, and that is not required, because for lower speed we require the lower dwelling period, and for higher speed we require the higher dwelling period. Now this is the variable wall timing with intelligence. So how we are achieving the variable wall timing? Now see here. So we have already seen it. So this is the crank. So you can say this is the crankshaft. So this is the camshaft. So this is the crank, and this is the camshaft. Now these two, we are in between, there is a scissor gear. So this is a scissor gear. So this is a scissor gear. So this is the scissor gear. Now see, now we know that the camshaft is controlled by the crankshaft. So this camshaft we are controlling with the help of the crankshaft, means some of the power we are utilizing to run the cam. So this is the camshaft is the auxiliary device of the engine. It is the auxiliary device of the engine. So whatever the power generated by the engine, so small power we are using to rotate the camshaft, and this camshaft will be open and close the valve. It will open and close the valve. Now we have seen that this camshaft in variable valve timing diagram, in variable valve time, this camshaft will be controlled by the two parameters. First one is the crankshaft. It will control by the crankshaft, and another one is the oil control valve. So oil control valve. So this is the first one, and this is the second one. This is the second one. So this is the second one. So this in variable valve timing diagram. So in variable valve timing, we are controlling the camshaft with the two parameters, that is the crankshaft and the variable valve, oil control valve. So oil control valve. So here again, this whole component we are controlling with the engine control management. So engine control unit or engine control management. So this will help, it will give the input parameter to the oil control valve, to the oil control valve. Now we can see that this we'll discuss how the camshaft will be controlled by the both the parameters. So now, so this crank, as the crankshaft having the higher speed, so cam will rotate with the higher speed with the help of the scissor gear, with the help of the scissor gear. Now this how oil control valve, so this oil control valve will apply the oil pressure over the camshaft. It will apply the oil pressure over the camshaft. So it will retard the speed, and so this oil control valve will retard the speed of the camshaft. ये कैमशाफ्ट का स्पीड कम भी कर सकता है और बढ़ा भी सकता है. कैसे करेगा? If crankshaft is rotating and due to it is giving the power to the camshaft, so this, if camshaft is rotating in this direction, as the crank is rotating in this direction, if this oil control valve will apply the forces in the opposite direction, it will apply the forces in the opposite direction, so then we can retard the camshaft speed. We can retard the camshaft speed, and that is required at lower speed at starting of the engine, at the starting of the engine. So what, how he will do when the engine, we are starting the engine, so engine control unit will sense the position of the camshaft. It will sense the position of the camshaft with the help of the cam sensor. With the help of the cam sensor, at the same time engine control will give the signal to the oil control valve, and if this crank is moving with lower speed, at the same time what this oil control valve, it will apply the oil pressure in the same directions of the in the same direction in which direction the crank is moving. Due to that, what will happen, the camshaft will rotate at higher speed. It will rotate at higher speed, and due to that the dwelling period we are reducing. What we are doing, we are reducing the dwelling period. We are reducing the dwelling period at the lower speed. We are reducing the dwelling period at the lower speed, and due to that, as we are reducing the dwelling period, so what will happen, the time will be reduced. The opening time of the inlet valve will be reduced, and whatever the charge is required, that charge will required for at lower speed will supply to the engine. It will supply to the engine. Again, in case of higher speed, now this crank is rotating at higher speed as engine is rotating at higher speed. So what will happen, this camshaft will rotate at a higher speed. So this is rotating at higher speed, so this camshaft will be also rotate at the higher speed. Now at this condition, so oil control valve will apply the pressure in opposite direction. It will apply to the opposite direction. Due to that, this camshaft will rotate at slightly at lower speed with reference to the crankshaft. It will at the lower speed, and due to, as this camshaft is rotating at the lower speed, so dwelling period will be increased. Forward dwelling period will be increased. Yeah, obviously this is very simple. as the camshaft is rotating, so these cams will rotate very slower speed. As this cam is rotating at slower speed, so dwelling area will not move at in small time, so it will require the more time. So we can say that the dwelling time will be increases, dwelling time will be increased. So this is the lift and this is the dwelling. So this time will be increases as cam is rotating at lower speed. So we have increased the dwelling time with the help of the this oil press. So these are the engine oil pumps. So this engine oil pump is supplying to the oil, pressurized oil to the oil control valve, and this oil control valve will decide so where we have to apply the pressure depending on the signal received from the engine control engine control unit. So this engine control unit, it will send the signal position of the cam, it will position of the cam, it will sense the speed of the crank, it will sense the speed of the crank, and depending on that it will give the signal to the oil control valve. So depending on that, it will apply the forces on the camshaft to retard or advance with reference to crankshaft. And with the help of this arrangement, mm, we can we can vary the suction charge with respect to load. We can vary the wall timing, we can vary the wall timing with reference to the load. So that's why we are calling this arrangement as variable wall time with intelligence, because it is giving the exact whatever the charge is required depending on the present condition of the engine. What is the speed of the engine is, what is the load of the engine is. So for that engine, how much charge is required, this will decide, and that much of charge will be for getting that much of charge, it will vary the wall timing so that he can operate the engine at better performance. At better performance. So this is the variable wall timing, and this is nowadays we are using in most of the cars which we are seeing today. So this much of so we'll stop over here, and we'll take the we'll discuss the two-stroke petrol engine in next lecture. Thank you.